Okay, so in this video, we're going to go over just example 5 in 4.6 day 2, which is inverse relations and functions. Example 4 is the same as examples 2 and 3, so you can go back and look at the video from day 1 for examples 2 and 3 if you have questions about those two problems. So the new idea today that we started with review is the idea that if two functions are inverses of each other, then the following is true. F of g of x is equal to x, and g of f of x is equal to x. So what that means is that if they're inverses, f of g of x is actually equal to g of f of x, which is something that we didn't see in the previous lesson when we looked at the idea of composition. And both of those are actually equal to x. Okay, so not only do they have to be the same, they have to be equal to x. So what we're doing here then is we're going to do each of these compositions to check to see if they're both x. So we're going to start with f of g of x. So if f of g of x means I'm taking f of x and I'm replacing x with the equation for g. So in this case, the equation for g is 1/2 x minus 5 over 2. Minus 5 halves. So that means that I'm taking that place of x in f of x and I'm replacing it with the whole equation for f. So since I have 2x, I'm going to multiply that times the whole equation for g plus 5. So I'm going to replace the x in f of x with 1/2 x minus 5 halves. I need to simplify this to see if it's equal to x. So if I have 2 times a parenthesis with multiple terms inside, I cannot combine my 2 terms, so I need to multiply. So 2 times 1/2 x is 2 over 2, so 1x. And then 2 times negative 5 over 2 is going to be negative 10 over 2, which is negative 5. And then I still have the plus 5 from the original function. So notice that if I combine like terms, that equals x. So right now what I have is that f of g of x is equal to x. So I have the first condition. The second condition is that g of f of x needs to be equal to x. Okay, so I want to check now if the second condition is true. So if I do the reverse composition, if I compose f into g, so I'm going to evaluate g at f when f is 2x plus 5. That means I'm going to take 2x plus 5 and place it in for the x in the function for g. So g of x is 1/2 x. So I'm going to do 1/2. I'm going to plug in f there, minus 5 halves. So I'm replacing x with the function for f, which is 2x plus 5. So structurally, this is the same process. I need to distribute the 1/2. So if I multiply 1/2 times 2x, that's going to be 1x. And then if I multiply 1/2 times 5, remember I want to think about the 5 over 1. So that's going to be plus 5 over 2. And then I'm going to bring down the minus 5 over 2 that I had from the original problem. So notice that if I combine like terms, I get x. So I've met the second condition that g of f of x is equal to x. So that means that yes, these two functions are inverses. So again, even though it looks like they should be because I have dividing by 2, multiplying by 2, and then I have adding 5, subtracting 5, I have to check to make sure that if I compose both the functions within each other, that they equal x as a result. So for B, I'm going to go through the same process. So I'm going to start with f of g of x. And my goal is that that equals x. So for this one, I have g that I'm plugging into f. So I'm going to plug in for this squared piece. I'm going to plug in the square root of x minus 5. So I'm going to evaluate f of our function for g is the square root of x minus 5. So in that x that I highlighted in f, I'm going to square that and then add 5. What I'm plugging in is the square root of x minus 5. So since we're squaring this square root of x minus 5, remember that means that I'm taking the square root of x minus 5 and I'm multiplying it times itself. And then I still have that plus 5 left over. So when we do this, we're distributing each of the terms. So square root of x times square root of x. The square roots, that becomes the square root of x squared, which is just x. Okay, so our first term is just x. Then we're going to multiply the square root of x times negative 5. Since the 5 doesn't have a radical, it's just going to become a coefficient. So negative 5 radical x is that term. And then we're done distributing the radical x, so we're going to distribute the negative 5. So negative 5 times radical x is also negative 5 radical x. And then finally we have negative 5 times negative 5, so that's going to be plus 25. And so when we bring down our 5 from the original problem and combine like terms, we have only this x. We can combine negative 5x with negative 5 radical x to become negative 10 radical x. And then 25 plus 5 is 30. So notice that this does not work. So this is not equal to x. And so what we know is that these are not inverses. I'm still going to go through and do it the other direction so that you can see that in practice. So the other direction is where we are going to evaluate g of f of x instead. And so that means we're going to plug f of x into g of x, where f of x is the equation square root of x minus 5. Sorry, where f of x is x squared plus 5. So we're going to plug x squared plus 5 into g. So we're plugging into this x here. So we're going to replace that x with x squared plus 5. So g of x is the square root of x plus 5. And we're going to write x squared plus 5 there. So because both the 5 and the x squared are under the radical, we actually can't even do anything to simplify this. And so notice that this is not x. And so this result means that these two functions are not inverses.